The first one is from Alexander and Sadiku, and it is practice problem 2.7. Okay, and the diagram looks like this. There's a 9 amp current source, and then there's a resistor of 2 ohms, and it's got flowing through it a current of I.O. And then there's a dependent current source, and the current of the dependent current source is I.O. divided by 4. And then lastly, there's an 8 ohm resistor. And it's got a voltage V out across it. Okay, so the first thing that you should notice is that all these elements are connected to each other in parallel. So this is one expanded node, and this is one expanded node. So everything is connected in parallel, right? And because everything is connected in parallel, we know that the voltage drop across all the elements is V out, right? And we've got 2 unknowns. We've got I out and V out. So we need to somehow eliminate one of the unknowns and get an equation that just has the other unknown in it so that we can solve for that unknown. Okay, so since the 2 ohm and the 8 ohm are in parallel, and because they're in parallel, the current I.O. by Ohm's law I.O. is equal to 2 ohms V.O. divided by 2 ohms, right? Everyone happy with that? Okay, so, and we can also write, let's call this current I.X. So we can also write I.X. in terms of Ohm's law. So we can write, and I.X. is equal to V out divided by 8 ohms. And now we can write the Kirchhoff's current law equation at this node. So we can say by Kirchhoff's current law, and remember Kirchhoff's current law says that the sum of the currents flowing into a node is equal to the sum of the currents flowing out of the node. So in this node we can see we've got 9 amps flowing in, and we've got I.O. plus I.O. over 4 plus I.X. equal to 9 amps. And we've written I.O. and I.X. in terms of V.O. So now we see by putting 1 into 2, we can end up with an equation with only one unknown. Okay, so we put 1 into 2, and then we get VO, IO is VO over 2, IO over 4 is a quarter times VO over 2, and IX is equal to VO over 8, and that's all equal to 9. So now if we multiply both sides by 8, then we get 4 VO plus VO plus VO is equal. Okay, so then we have on this side, we've got 6 VO is equal to 72. And so VO VO is equal to what? 72 divided by 6? 12. Okay, 12, yay. So we know that VO is equal to 12 volts. Oh yeah, that's true. Okay, and now since we know VO, we can also calculate IO. So IO is equal to 12 volts divided by 2 ohms, and that's equal to 6 amps. Okay, and that's the solution. That's the solution to that problem. Okay, everyone happy with that?